this. This is a quick overview of a formal definition of limit. When we talked about Subway sandwiches, did we talk about Subway sandwiches yesterday? How they made Subway sandwiches footlongs, 11 inches? You know, you got to give them a little credit. They could be, you know, an inch, give or take. But what they found was they were always an inch short. Always. They were never larger. And so because of tolerances, you should have a little bit equal above and below. But what this means to us is that in order to find out what this limit is, limits are what again? Oh yeah, y values. So we're trying to find the y value when x approaches something like infinity. Okay? So what you're going to do is the first thing you're going to show is a connection between this tolerance and this tolerance. You're going to show a connection between the two. And once you show that connection, then you're going to say, all right, when x gets really, really big, what happens to the spacing epsilon? All right, so what's epsilon? So let's talk this out. This is x, the difference between x and a value, a tolerance, we're going to call delta. That's just, I call it a skosh. Is that a cooking term, skosh? You add a skosh or push, I don't know. Yes? It could be. They only have so many Greek letters. Yeah, they also use it for standard deviation. Epsilon is how far off it is in the y. And so difference in the x, difference in the y. And what we're going to say is that if you were to look at any value of u of x here, any value, if you subtract the limit, the y value limit, L, u of x minus L, the absolute value of it, give or take, needs to be this epsilon. That's the connection. So if you take u of x minus L, the absolute value of that, above or below, has to be less than epsilon. And that's what we have to prove. So let's do it. We can do it. So we're going to show the relationship between x and epsilon first, and then we'll take care of part 2 later. So tell me, what's the limit as x goes to infinity of 3x over 2x plus 1? Do you remember how to do this? Divide everything by x, and you're going to get 3 over 2 plus 1 over x. And what happens to this 1 over x as x goes to infinity? 0. So what will this limit be? There you go. 3 over 2. 3 over 2. Okay, so once you know that, you know what L is. So then we're going to set this up. U of x minus L has to be less than epsilon. So now we just plug in. For u of x, it's 3x over 2x plus 1. That's the formula. U of x. And what did we say L was? 3 over 2. That has to be less than epsilon. Okay, we're going to show that relationship. Okay, so what do you do if you're going to subtract two things? What do you have to get if you're in a fraction form? Common denominator? Good. So let's do it. 3x over 2x plus 1 minus 3 over 2. What are you going to multiply top and bottom by? This one's going to be 2x plus 1. And what's this one going to be? 2. Okay. Give you a chance to write that down. Less than epsilon. So this is going to be 6x over 2 times 2x plus 1. I'm not going to multiply it out. Minus 3 times 2 is 6x minus 3 over 2 times 2x plus 1. I'm showing a little bit of extra algebra steps, but sometimes that's helpful. What happens to the top? Those are going to cancel. And so you're going to get the absolute value of negative 3 over 2 times 2x plus 1 is going to be less than epsilon. Now, what's the absolute value of a negative? A positive. So this is going to be 3 over 2 times 2x plus 1 is going to be less than epsilon. This is my relationship between x and epsilon. It exists. That's part one. You just get a formula. There's a relationship between those two. Watch your signs here, but it worked out. That's part one. Part two. Part two is my favorite part. So once you've got this relationship, here's your limit, and this seems to be trending a little bit. There's a relationship between this function u of x or f of x and epsilon. So once you know that, we want to know when x gets really big, let's say we start at 10 and we go to 100. These are arbitrary numbers, but it would work if this relationship exists. Let's see what happens to epsilon. Okay, so here's your relationship down here. 3 over 2 times 2x plus 1. 3 over 2 times 2x plus 1, okay, is less than epsilon. And so what is 3 over 2 times 20? What is that, 3 over 41? Does that sound right? Is your epsilon value. Now let's see what happens when you put in a 100. 3 over 2 times 100 plus 1. So 3 over, what is that, 401? 401. Okay. Which is bigger, 3 over 41 or 3 over 401? 3 over 401 is smaller, so 3 over 41. So we can say, therefore, this is a shortcut for therefore, 3 little dots, since, I'm not going to say since, I'm going to say as, x increases, epsilon does what? 3 over 41 to 3 over 401, x decreases. Yep. Let me double check with my formula. Good point. 2x plus 1 is in parentheses, so you're right. It should be 42 and 402. Thank you. Missed that. As x increases, epsilon decreases. Then, big therefore, big triangle of dots, the limit exists. Because you showed a relationship, and you showed that as x gets bigger, epsilon decreases, then the limit exists. Come on, that's pretty amazing, isn't it? Pretty amazing that you can do that. Let's do an easy one. You want to see an easy one? Okay, let's do an easy one. I'm going to do example 2. Let's go u of x, or f of x, is going to be there you go. So you have u of x is equal to this, and you're going to prove that the limit as x approaches infinity of u of x, what's that limit going to be? 0, yeah. Would I be this nice on a quiz? Probably not. I'm not very nice. I should be, though. That's a good point. So u of x minus L is less than epsilon. So we have 1 over x plus 2 minus 0 less than epsilon. Well, 1 over x plus 2, is that a relationship? Therefore, a relationship between x and epsilon exists. Just use arbitrary numbers. X equal to 10, x equal to 100 are simple. You can use 10 and 1,000, whatever you want. So then you go 1 over 10 plus 2, it's an epsilon, which is 1 over 12. And then the next one, you're going to do 1 over 100 plus 2, it's an epsilon. So this is going to be 1 over 102. As x increases, epsilon does what? Decreases. Okay, and therefore, limit exists.